Thanks for being here. Take it away.
Thank you so much for having me and for the nice intro, Cody. I really appreciate it. I'm also excited to just keep talking about caching. I love that Matteo kicked it off so well, and now we're going to focus a little bit more on the complexities around edge caching and what that does to your API. Like Cody said, I am Max. I am one of the co-founders of GraphCDN. I co-founded it last year with my good friend Tim. I've also created a bunch of open source projects in my life, mainly in the React ecosystem. If you've heard of styled components, React boilerplate, polished, a bunch of them I was responsible for. And I'm really excited to dig into this edge caching story. All of this really started for me back in 2018. In 2018, I was working on another startup called Spectrum, and we were building sort of this modern community platform, right? We were trying to give open source projects a better way to connect all of their people. And, you know, if you think back to 2018, people were using Gitter, people were starting to use Slack, Discord wasn't really a thing yet, and we really wanted something that was public and indexable, right? So that when somebody asked a question about style components or React boilerplate, other people could then find the answer that we give on Google. And we wouldn't just get the same question again, which was the perennial problem with Gitter and Slack. People just didn't search them. And so people just kept asking the same questions over and over. And so we were building Spectrum, and it was actually growing really well. A bunch of big open source projects, including Apollo and Zeit with Next.js, and we're now called Vercel, of course. All of them were using it. And so we ended up getting a lot of users and a lot of traffic. And by 2018, I think this must have been like the beginning of 2018, like January. I remember shortly after Christmas, we started crashing every single day. And I mean, literally, our platform would be down once a day, every single day. Essentially, our servers were just on fire. I actually Googled servers on fire a while back and found this absolutely insane stock photo of servers on fire. I sure as hell hope that your servers don't look like this. If they actually start looking like this, you have a massive problem because your data center is actually on fire. But our servers were just crashing, right? Specifically, our database was way overwhelmed. We'd chosen a pretty terrible database called RethinkDB, and no harm to that team, right? They really tried to build something new. It didn't work out, and they eventually shut down the company. But RethinkDB just did not hold up with our load, and it was really frustrating. And, you know, I thought to myself, you know, we're building this publicly indexed, basically a modern forum, right? Our API is super read heavy. Most of the requests we get are read requests. Comments are written, but not very often. The data is mostly public, right? Yes, we also had DMs and there were some private communities, but most of it was just public. So very read heavy API, very public data, basically ideal use case for caching, right? And I looked around, and nothing existed. We were using GraphQL, and we were super happy with GraphQL because it allowed us to move much faster and build a much better API and client. But you couldn't cache a GraphQL API. And so I wish I actually had Matteo's solution back then, because that would have solved a lot of our problems, right? It would have solved a lot of our scaling problems, but it didn't exist. And so I actually built a terrible version of what Matteo's built at Spectrum internally, and it never really worked. And we were using Redis, like Matteo said, that wasn't maybe the ideal choice. And overall, it just wasn't the great call. On top of that, it was really slow. Our data centers were in Virginia. Of course, US East 1, that's where most people host their data centers. But I'm in Europe, I'm in Austria, right? We had users everywhere around the globe, right? From Australia, over Asia, over Europe to the US and South America. We had people everywhere. And so I was like, well, actually, you know, if I think about a GraphQL client, kind of what a GraphQL clients do in Apollo Client, Relay, Urkel, kind of what they do is cache GraphQL queries. So can't I just take this thing, can I just take the same logic that Apollo Client or Urkel or Relay have internally and run that at the edge? Can I just take a GraphQL client and run it at the edge? Now, in order to understand how these GraphQL clients work, let's take a quick look at GraphQL clients, at how GraphQL clients cache. Now, I know that Matteo just talked about caching, so I'm going to skim over this really quickly, but basically, it all boils down to the magic __ type name field, right? GraphQL objects have this field for every single object. And so you can actually identify what data comes back from this query by looking at the type name field. In this case, we're fetching a blog post and its author. And when the response comes back, the response tells us that it is the blog post with the ID 5 and the user with the ID 1. GraphQL clients look at this, they take the type name, they take the ID, and they store it in the cache, keyed as post number 5 and user number 1. Now, why do you need this, right? The next time the same query comes in, of course, you can just serve the same result, easy money. But the really magic part here is mutations. Because GraphQL differentiates between queries and mutations, now when an edit post mutation comes in, we can know what changed, right? Similarly to the query, we add the __ type name field. And when the data comes back from the mutation, here we've changed the title of the blog post, right? The data comes back from the mutation, then we can look at the response and we can be like, oh, you changed the post with the ID 5. Let me invalidate that, right? And so we can then invalidate, or GraphQL clients can then invalidate things that are in the cache. Unfortunately, there's an edge case. The edge case is list invalidation. Imagine if you have a query that fetches a list of blog posts, right? And the response in our example here just looks like this. There's only a single blog post with the ID of 5 that has a title of how to edge cache GraphQL APIs. The problem is, what happens when you submit a create post mutation, right? We're just going to create another post. The post data comes back from the API, but of course, our cached query result doesn't contain the post with the ID 6. It only contains the post with the ID 5. That's frustrating. And so for these cases, GraphQL clients make you manually implement invalidation, right? And so for example, in Urkel, you have this updates configuration where you can say, okay, when a create post mutation passes through me, then let's invalidate any query that contains the query.posts field that fetches a list of blog posts. But that's the main edge case that GraphQL clients have to deal with, is just list invalidation, and then that's it, and everything else works beautifully. And so really the takeaway here is that GraphQL is incredibly awesome for caching, right? GraphQL is just fantastic for caching. So let's go back to my original question. Can't I just run a GraphQL client at the edge? And let's zoom in a little bit on the edge bit, because that's where it starts getting a little bit tricky, right? The GraphQL caching bit, all right, but the edge bit, not so sure about that. The first thing you run into is author. If you have access to the same browser, you're the same user. So a GraphQL client does not have to worry about authorization at all. Zero. It's always going to be the same user sending queries, and so they can always just assume that they have access to the data that they have in the cache. That is not the case as soon as you're running at the edge, right? The whole point is that you want to share the cache between many people so you can have a high cache hit rate. And so ultimately, you now have to deal with authorization, and you have to deal with how people authenticate with the service that you're caching. Thankfully, most people use either authorization headers or cookies. And the solution to handle authorization at the edge is really to extend the cache key. Like Matteo talked about, you sort of take a hash of the query as the cache key, but then you also add a hash of the token of the user. And what that does is, when some public user fetches data, then we know that the response is public because they won't have a token, and so the cache key will just be the hash of the query. And then that response will be served to all the users. When a user fetches data that is authenticated, that has an authentication token, then the cache is going to bail out and be like, no, you get your own sort of cache, right? You get your own sort of set of data that if you fetch that again, will happily respond with it. But it's your private data, and we can't just assume that everyone should have access to this. There's actually another layer to this where just taking the token is the simple solution, but we've now actually introduced a mechanism whereby we can cache by a JWT, which, by the way, who calls them JOTs? In the JWT spec, people say that you should call JWTs JOTs. I've never heard anyone say call them that. Anyways, I'm just going to keep calling them JWTs. JSON Web Tokens, JWTs, you can claim something, right? And so we actually support now caching things by a claim. And what that allows you to do is create groups of people. So for example, if everyone in Spectrum is in a private community, they all have access to the same data. And so we could have created a JWT claim for that community and let the user configure and tell us that, the community posts query, you can actually cache that for this group of people rather than just for each individual person, which increases the cache hit rate massively, of course, for authenticated users and makes their experience much, much better. The second thing you deal with, again, is global cache purging, right? Locally, you can invalidate things in memory. In the browser, everything is just in memory. You can simply kick it out and it's done. As soon as you're running at the edge, you have many locations worldwide. Suddenly, you have to deal with global cache invalidation, right? You have to purge things from your cache everywhere around the world. And this is really tricky. Thankfully, we didn't have to solve that problem because Fastly already solved it for us. We use Fastly's computed edge infrastructure as our underlying infrastructure at GraphCDN. And Fastly has fully solved this purging problem. They use gossiping algorithms under the hood, and they can actually invalidate cache data globally in 150 milliseconds. Now, just to put that into perspective, how fast 150 milliseconds is. The average human blink, so this is 300 milliseconds. So in the time that it takes me to blink once, which is in the blink of an eye, Fastly can actually invalidate data globally in all of their 70 data centers twice. That's bonkers fast. 150 milliseconds. I actually looked this up once. I was curious and I was like, okay, 150, that seems very fast, right? Like to go around the entire world, how fast is even the speed of light, right? And it turns out that at the speed of light, it takes about 133 milliseconds to cover the entire globe. And so I was like, there's no way that Fastly can invalidate data in 20 milliseconds faster than it takes the speed of light to cross the Earth. There's no way that that's possible. And so I looked into it, and actually, they're not stupid, of course, they're very smart. They don't go around the globe once. They go in both directions at the same time. They have a gossiping algorithm that essentially jumps from one node to all of its surrounding nodes, and then from them to all the surrounding nodes. And so it's just constantly going around the globe in sort of like a networked fashion. And that's how it can be so fast, because it only has to cover half the globe at most, right? Instead of going around the entire globe. Anyway, so Fastly has incredibly fast invalidation. And they also have 70 data centers worldwide, spread pretty much everywhere there's people, right? Which is really awesome for us because running that infrastructure is really, really, really difficult. How maintaining 70 edge locations worldwide is not something that we want to do as a young company. We just want people to be able to rely on us. And so us being able to use Fastly's infrastructure makes our life much, much easier. And the purging is just so incredibly fast, which is really beautiful and very excited about that. Now, the next problem you then deal with once you've solved this global cache purging problem, where, by the way, GraphCDN allows you to purge by specific objects. So you can tell us the post with the ID 5 has changed, and then any cache query result, because of Fastly, that contains the post with the ID 5 is gone in 150 milliseconds, which is really powerful. But of course, the question then becomes, okay, now I have 70 locations worldwide. Won't my cache hit rate be really low? Like, if I have users everywhere, then all of them are going to hit different points of presence. And also, my API looks like X, right? At GraphCDN, we've now seen thousands of GraphQL APIs. Is it even worth it for me to cache this stuff? Well, what we've learned is that there's sort of a 4-quadrant diagram on how high your cache hit rate will be, right? And I've sort of sketched this out here. There's an axis where it's like how public or private is your data, right? Is it very public like it was at Spectrum where all of the posts were basically public? Or is it very private, right? Like a messaging service where every user has their own data set. And then the other axis is how often does your data change? How read or write heavy is your API, right? If it's very read heavy like it was at Spectrum, great for caching. If it's very write heavy and constantly changes, then you're going to have a really low cache hit rate because the data won't be able to be served from the cache, right? And the two extremes that I put into this graph here are a news website in the top right corner. News website, ideal use case for caching, right? Very public data. Basically, the same article gets read by millions of people potentially, and also very read heavy, right? One author writes the article once, and then that same piece of data gets read by millions of people. super high cache hit rate. I'm going to show some customers afterwards, but our customers who have news use cases have 99% plus cache hit rates globally. So in total, across all of the 70 edge locations, they have a 99% cache hit rate on their most important queries, which is huge. On the other end of the spectrum, on the other extreme, would be an error tracking service, right? An error tracking service is extremely write heavy. Error tracking services ingest millions of data points, then process them, aggregate them, and then it's very private data that barely gets looked at, right? These errors are very specific to you. They're super private, and you hopefully only ever look at them once and then fix them. Now, of course, you might look at them 2 or 3 times or maybe 4 times, right? But really, you're looking at data that changes millions of times, but gets looked at once or twice. If you were to add caching to an error tracking service, that would be practically useless, right? You would have a 0% cache hit rate, which is also why I don't have a customer there. I don't have an example error tracking service customer because none of them use GraphCDN, and for good reason, right? Why would they? The other thing we've learned about this sort of cache hit rate conundrum of edge caching is that most GraphQL APIs fall somewhere in the middle of this spectrum, right? For example, an e-commerce store has some really public, really read-heavy queries. The product queries, right? When you're looking at a product list or an individual product, that product is the same for everyone. It changes pretty rarely. Lots of people look at it. Ideal use case for caching. However, an e-commerce store also has a shopping cart. And that shopping cart is super private and very write-heavy, right? That shopping cart is specific to you and you only. And you probably add more products to it than you ever look at it, right? If you think about a product that gets published once and then looked at millions of times, compared to a shopping cart, which gets written to 5 times maybe and then looked at once or twice, it's a big difference. And so what we've learned is actually most GraphQL APIs have a mixture. They sit somewhere in the middle, and they have certain queries that are a lot more valuable and easy to cache, and other queries that are pretty difficult to cache, right? And maybe don't even make sense to be cached. And so GraphCDN actually has to give you full control over your cache configuration on a per type and field level even, right? We allow you to say, okay, if somebody fetches a product, then please cache that for 5 minutes, right? But if somebody fetches a shopping cart, then you know what? Let's not worry about caching that. It's not worth it. Let's just pass that through to the API directly and just serve that dynamically every time. And so you have this very fine-grained control over your cache behavior, over what you want to cache for how long, which is incredibly powerful, and a lot of our customers use that to great success. Another piece of this is once you're running at the edge, you can implement Stale-while-revalidate. And again, we let you configure this on a very fine-grained per type or per field level. But the way this works is once something is in the cache and you tell us, hey, look, the post with your D5 has changed, instead of being purged immediately and the next query having to go all the way to your origin, the user having to wait for your API to respond, coming back to the client, and only then seeing the data, Stale-while-revalidate defines the time frame in which the data can be stale. What that looks like in practice is the data gets purged from the cache and hits the Stale-while-revalidate, goes into the Stale-while-revalidate time. A user tries to fetch that data and gets served the cached response immediately, right? They just immediately get the response since it is still in the cache. It is still stale, but it is in the cache. In the background, our edge then refetches from your origin the fresh data, which will take a while. And then as soon as that response comes back, it updates the cache, and the next user that requests the data gets the fresh data. The powerful thing about Stale-while-revalidate is that it gives your users a super fast experience always, with the trade-off of the data being maybe a second or 2 out of date, which is, for many use cases, a perfectly fine trade-off, right? Your users having a much faster experience always is totally worth the data being 1 to 2 seconds out of date for a lot of use cases, and works really, really well. And that increases your cache hit rate, because on top of that, Stale-while-revalidate can deduplicate requests as well. If 2 users fetch some data that's stale and being revalidated, both of them will get the fast response, but only one request will be sent to your origin to refresh the data. So Stale-while-revalidate is super powerful, and something that I'm very excited we have and a lot of our customers use very effectively. Now let me give you some examples of the impact that edge caching has had on some of our customers. One of them, Patronage, builds on sort of political advocacy, right? They build websites for all kinds of political campaigns in the US, which means these websites, they get a lot of traffic and then it's very constant, right? And they'll when people start talking about those political initiatives, they start ramping up very quickly and growing very quickly. And they were having huge server load and thus performance problems. And here you can see how their web transaction time, this is a screenshot from their own sort of backend hosting platform. They're using WordPress GraphQL. And you can tell exactly at what moment they deployed GraphCDN to production because all of the metrics just fell down. Same thing is true for their serverless execution function. So they are using a stack of Next.js that fetches data from WordPress GraphQL. Essentially, the Next.js API routes were having to wait for WordPress GraphQL every single time they fetch some data. And so they were paying Vercel a lot of money because these functions were idle, but they were still executing, right? And again, you can tell the second they deployed GraphCDN, their serverless function execution RAM dropped dramatically by a factor of, I think, 100x, like much lower, which makes, of course, me really happy. Another customer of ours over at Funkhaus, who built the Flood magazine website, they deployed GraphCDN to production, and he sent me an email. Actually, he was like, check out the attached screenshot of the server load for floodmagazine.com. Can you tell when we deployed GraphCDN? And of course, they deployed it on February 22nd at about 4 p.m. maybe. And you can tell immediately that the load on the server is way lower. And again, these are both sort of news use cases, right? So both of them have a 99% cache hit rate across the network. Their origin has to handle 99% less GraphQL traffic, which is mind-blowing to me, right? And their users have a much faster experience. Another one of our customers, Italic, is a really famous online store. If you haven't checked them out yet, they have some really cool stuff. Essentially, their whole thing is that they're a marketplace for unbranded goods. You can get the same bags, the same duvets, the same everything that big brands sell, but without the logo and thus much cheaper. And they implemented GraphCDN after they crashed a bunch of times last Black Friday. And in preparation for this Black Friday, they were like, you know what? We need to put caching in front of our GraphQL API. We're just going to crash again if we get this traffic spike, right? Like, we put caching in front. And they got to 500x reduced database load because they're sitting at a, now I think 75% overall cache hit rate, right? So that includes all of the shopping cart queries, which they don't cache. Their main sort of most highly requested queries, the product queries, those are sitting at a 90%, 95% plus cache hit rate, which is incredible, right? And so they actually, this Black Friday, zero downtime, no problem at all. They had a huge traffic spike and they had no problem at all. Point being, edge caching is an incredibly powerful tool to increase the performance of your GraphQL API for your users and simultaneously relieve a bunch of load from your backend so that it doesn't have to deal with as much traffic anymore and as many repeated requests. Now, once we had this edge caching solution, we realized that actually there's a bunch of other interesting stuff that we can do now that we're sort of at the edge in this GraphQL gateway. So GraphCDN now also has edge retries. We offer operation level analytics so you can see how fast your queries and mutations are and how high their individual cache hit rate is. We offer performance monitoring, like I just talked about. We do error tracking. We track every error that comes back from your API. We alert on those, so we can send you alerts via Slack, email, PagerDuty. We can tell you when your API is getting slow, when you have a bunch of errors, when there's a spike, right? No problem at all. We can tell you about that. We give you schema usage insights. We can tell you, these two types haven't been used in 5 days. This type is deprecated, but is still used. We give you those sorts of insights. And there's a bunch of other stuff we do as well that I'm happy for you to check out the website and just see what we do. But there's a bunch of stuff that we can do now that we're in this interesting position of being an edge GraphQL gateway. Now, what we want to work on in the future is making GraphQL caching more usable and improving our clients' cache hit rates, right? And one of the ways we want to do that is normalized caching. I'm not going to go too in depth here, but essentially normalized caching is something that GraphQL clients do where they normalize the queries that come back. So if we go back to our blog post query, right, we got back a post with ID 5 and a user with the ID 1. Rather than just storing this entire query in the cache as a full document, as a full response to the operation, normalized caching splits it up into caching the data of the post with the ID 5 and the data of the user with the ID 1. And then there's also a separate table there where it sort of has the relations and explains those. But the point is, you now have the data of the post with ID 5 separate from the data of the user with the ID 1, which allows you to do all sorts of cool optimizations. If somebody sends a query that fetches the user with the ID 1, you now already have that data in your cache and you can respond with it, which is really, really powerful. Another thing we're thinking about is eager mutation invalidation. So if we go back to our create post mutation, what if we could actually figure out which lists that affect it, right? What if we could automatically figure out, okay, you've created a new post, let us just eagerly invalidate all lists that contain a post. Now, you're going to have a lower cache hit rate than if you manually implement invalidation for that, but it's a lot more easy to set up. And so those kinds of topics are really what we're thinking about here. And I know I'm getting close to time, so I won't get any more in depth, but essentially, it's our job now to make sure our users have the highest cache hit rate possible and that they can use GraphQL caching for the most queries possible. And I'm really, really, really excited about that. That's everything I have for you today. Thank you so much for having me. I'm really excited that I got to speak after Matteo, who I'm a big fan of. And if you have any questions, feel free to ask me or feel free to hit me up on Twitter at MXSDBR. Happy to answer anything.
Oh, that was great, Max. Thank you so much. I really love talking about caching and the little piece at the end about the normalizing the data. I personally have some questions for you about that, but I'll just give it a second here, see if we have any questions from the audience. Feel free to post those questions in the Q&A tab on the right-hand side of your screen. We'll ask them live to Max right now. So Max, while you were speaking, I went and checked out your website for GraphCDN because I was wondering, well, what if I'm just kind of fooling around with a personal project, or I'm working on an open source project and I want to see what GraphCDN can do. So what do you have any, do you have a free plan for open source projects, or people are just kind of hobbyists fooling around?
Me up here. I appreciate it. GraphCDN is completely free for any developers using us for side projects. So if you have a side project, you can use GraphCDN entirely for free, no matter how many requests or how much traffic you have. That was really important for us and was actually a change we made recently because we realized, we originally our free plan was 5 million free requests, but nobody knows how many GraphQL requests they have in a month, right? That's not a number that people have in their head. So we were like, you know what? That's actually kind of, why do we even, that's generous, and we know that, but nobody else knows that. So let's just be generous and have everybody else also know that. And so we just made it free for developers for side projects, which, we're developers. We're both, me and Tim, my co-founder, we're both developers. We've both built a lot of side projects in our life, and we love supporting developers.
Yeah.
So if you're a developer and you're like, look, I want to try this out, just sign up and you put us in front of your GraphQL API. It's completely free for you.
Cool. That's so cool. That's I love services like that because I can just kind of get my hands dirty and see what's possible, right? To add some performance in my project. On the normalizing the data for the cache. So if you normalize that data, like you said, you kind of break it down into the different objects with their separate IDs. Does that mean you can optimize if part of the query is in the cache and part of the query isn't in the cache? Can you somehow optimize and only modify the query that actually gets sent to the server? Is that the magic behind that?
Yes,
Wow.
maybe. That's one of the possibilities, right? I think the easy, obvious case is, I fetch the author of a blog post, which is the user of the ID 1, and then I just want to fetch the user with the ID 1. Well, we have that data in the cache already, right? And we can just serve that. But equally, if we have the post with the ID 5 in the cache and we know that you're fetching that, and then you're just also fetching the author, maybe we can actually just fetch the user, we don't actually have to fetch the blog post as well since we already have that in the cache, which becomes even more powerful with stream and defer. If you can stream and defer certain parts of the query, then maybe that can actually already show up in the UI while we're fetching the author in sort of in the background, still having split the query at the edge. So there's some really powerful possibilities there that we might get to. I don't want to promise anything because a lot of this is very finicky, and tricky, can be tricky to implement.
Sure.
So we'll see how far we get. But essentially, that is our job now, right? For all of our customers, I'm hoping that a year from now we can look back and be like, we've increased all of their cache hit rates, right? We've helped them decrease their load even more. We've helped them increase their performance even more. That's what gets me up every morning, right? People crashing on Black Friday, and then the next year they're just perfectly fine. Italic just no problem at all this Black Friday, right? That makes me happy. As a founder, that just makes my heart all warm and fuzzy. So if we can do more of that, I love it.
That's so cool. That is so cool. We do a lot of consulting at NearForm, and when you can see the impact
Right.
that
So good.
those changes make, and like all of a sudden the next year everything just works perfectly and everyone's amazed. Like, how is that even possible? It's a really fulfilling feeling. Awesome, Max. Do you have any closing comments before you go? Thank you so much.
I mean, look, people, thank you for listening. If you have any questions about GraphCDN, if I can help you in any way, just feel free to ping me anytime. Happy to answer in.
Great. Thanks, Max, so much. Like Max said, keep the questions coming. You can still post them in this event, and we will send them to Max. We'll send them back to you. We'll make sure they get answered. So don't hesitate to do that. Thanks, Max. Have a good day, and look forward to seeing you soon.
Thank you for having me.